Hello, this is Schedulytics and welcome to today's session. In today's brief video, we are going to see how we can run the Poisson regression model using SPSS. If you watch our previous video where we use the Stata platform, you'll be able to know how to use the Stata platform to also run sync. But in this video, our attention or focus is going to be on how we can use the SPSS platform to be able to do that. So without wasting much time, this is a dummy data set about pregnant women in a particular geographical jurisdiction. And we are looking at the number of times they have episodes of diarrhea during their periods of pregnancy of 9 months. And so we're going to see what we can do by going to analyze. And first of all, diarrhea episode during the period is a count outcome, and so it's satisfied for us to use for a poisson. Now, to run that, we'll go to generalized linear models, and then we'll click on generalized model. And then earlier on, I ran this, so very likely when we go to the various parameters, you realize that there are some inputs there, but we would still go about it again so as to refresh our mind when we are doing it for the first time. And so the default setting is that it's on linear. So this is a count outcome. So we are looking at Poisson log linear. And our response variable, as I mentioned, is the diarrhea episodes. So we'll come here and select it and send it to the dependent variable section or column. And then we'll select our factors and then covariates. So as I mentioned earlier, I ran it earlier. That is why they were here. So we'll select this and send them back. So our age is a continuous or quantitative variable, so it becomes the covariate. And then we have the sex, marital status, occupation level as our factors because they are categorical outcomes. And then we will fit or we select all of them into the model. And so we'll come here and select our factors and then put them into the model and then maintain it as main effects. Now, that estimates are we anticipating. We want to maintain them just as it is with the default setting. Now, when it comes to the statistics, we also want to allow it just the way it is, but then we'll select include exponential parameter estimates. And then this will also be left the way it is. And then we are done. So we click on OK. Within the shortest possible time, we have an output in the output window. So we go there just to have a look at what has been presented to us. So generally, it gives us, so this is a generalized linear model. It gives us the model information, the case processing summary, and gives us the categorical variable information. Also gives us the continuous variable information, and gives us the good chi-square goodness of fit test. So this value helps us to be able to know whether our variable is or our model is being under dispersion, over dispersion, or equi-dispersion. So when the value is 1, then it means there's equi-dispersion, less than 1 under dispersion, and over 1 is over dispersion. And we can take a decision on that. You may want to watch our previous video where we look at the assumption checks to be able to know how you can make good use of this value, the value divided by degree of freedom. Now, we are interested in also looking at the archaic information criteria and then the Bayesian information criteria. These are model information criterion or criteria that will help us to be able to say whether one model is better than the other. So when you run 2 or more Poisson regression models and you want to see which one performs better, you want to look at the archaic information criteria, the Bayesian information criteria, and the lesser this information criteria, the better performing the model is. Now, we also have the omnibus test and the significant level, as well as the likelihood ratio chi-square values. Then we have our test of model effects. So how does each of the variables predict or contribute to the outcome of interest? So here we have the value or the significant levels less than 0.05 is a significant result. But as we can see here, none of this is less than 0.05. So scientifically or statistically, we can't make any valid or conclusive deductions out of what we have. And so we would say that there's a lot of chance elements in what has happened, and for which reason we will not want to make any scientific deductions. Now, this value here presented, exponential beta values, are key in helping us to do comparison within the reference group and the individual categories that are presented. So just as we interpret odds ratio values, this can also be interpreted this way. So basically, this is how you can be able to run a Poisson regression model using the SPSS platform, giving a count outcome and satisfying the assumption checks. If you find content such as this useful, we encourage you to continue to like our videos and share with all. And if you are a new subscriber, we want to encourage you to keep coming to learn. And if you are yet to subscribe, we encourage you to smash the like button and the subscribe button, turn on the post notification button, so you are always notified whenever a new video is released. Until we meet again on our next one, this is Catalytics, and it's a bye.